Hello students, welcome to the lecture series on ratio and proportions. So today we'll be delivering the lecture number 1 of this topic. Okay. So what we'll be covering in this topic is the concepts, types of problems on ratio and proportions, and we'll be doing various exercises, and then we'll be covering previous year questions. Okay. So in this first lecture, what we'll be covering is we'll be covering some parts of the concepts and some types of problems on ratio and proportions. Okay, so let's start this lecture. So in everyday life, okay, to scale recipes, to determine discounts, make solutions, compare quantities, okay, and adjusting recipe serving size or comparing prices, ratio and proportions are essential tools for practical mathematics. Okay, so if you are given a recipe, okay, that is for 1 kg paneer, you need 50 gram salt, okay, and 30 gram masala. Then how much masala and salt do you need for 30 kg paneer or 300 gram paneer? Okay, 300 gram paneer. These kind of questions can be solved by ratio and proportions. Okay, so let's start. So what is ratio? So ratio is a comparison between two quantities. Okay, you have given a quantity some x and some quantity y. So you want to do what? You want to compare. Then that's where the topic ratio comes into the picture. Okay, so comparison between two quantities typically expressed as A is to B or X is to Y if these two are unknowns. Okay, or it is pronounced as A to B. Okay, so it represents the relationship or relative size between the two values. Okay, so it represents the relationship or relative size between the two values. So how A is relative to B or B is related to A. In case of unknowns, how x is related to b or x is with respect to y in size, okay, and y is with respect to x in size. Okay, so for example 3:2. Okay, so in terms of size or quantity, okay, how much bigger or lesser is 3 with 2 or 2 with 3? Okay, that kind of relationship is called ratio, and we represent it as this. So this is pronounced as 3:2. 3:2 or 3:2. Okay, any one of these can be correct. Okay, so let's see the kind of ratios. Okay, the types of ratios. So there are basically 5 types of ratios. Okay, 5 types of ratios. So the first one is simple ratio. Then comes into the picture of the concept of compound ratio. Then we see what duplicate ratio is. Then we see continued ratio, triplicate ratio. Okay, these are all important kind of ratios or types of ratios. Okay, let's see in detail each of these kind of ratios and see their significance and how to use them to manipulate different numbers and get our answers. Okay, so let's see the first kind of ratio, that is the simple ratio. Okay, this is the first one and the very basic one. This is very fundamental one. So this is a very basic comparison between two quantities. Okay, you have given two quantities. For example, we have got 2 and 3. Let's say you have two quantities x and y. Okay, and we write it as this x to y. Okay, or 2:3 in this case. Okay, so for example, there are 4 red balls and 6 blue balls. There are 4 red balls and 6 blue balls. Okay, you can see here that these two quantities are being compared here in terms of quantity or their characteristics. Okay, so it's simplified as 2:3. So 2:3. So 2:3 will be their simple ratio. Okay, so let's see the second type of ratio, that is the compound ratio. So compound ratio is the result of two or more ratios being multiplied together. So you have two ratios, A is to B and C is to D. What you do is you multiply these two. So this can be also written as A by B and this can also be written as C by D. Then what happens is if we multiply these two, okay, then what we are left with is AC by BD. Okay, that is equal to AC is to B, D. Okay, so this kind of ratio is called compound ratio. Okay, so this kind of ratio where two ratios are being multiplied together is called compound ratio. So this comes into the picture after simple ratio. Okay, in simple ratio what we do is we simplify ratios. Okay, and in this case what we do is we multiply two kind of ratios and get another one. Here in this case we multiplied A by B with C by D, and what we got was AC by BD. Okay, so we wrote it as AC is to BD. Okay, this is called compound ratio. Okay, so let's see the third kind of ratio, that is the duplicate ratio. Okay, duplicate ratio is nothing but you are given a ratio A by B, let's say. Okay, and you multiply a constant with it, M into M in the numerator and the denominator at each time in order to get equivalent ratio. Okay, so what you are left with is AM by BM, right? But a thing to remember here is M is not equal to 0 and also B is not equal to 0. Okay, because if we take any of these two 0, then the whole thing will become undefined. Okay, so we won't take these two as 0. Okay, A can be 0, M can be 0. Okay, sorry, M can't be 0, A can be only 0. Okay, so the new ratio will become what? AM by BM, some other number, right? So this is called duplicate ratio. So duplicate ratio of what? Duplicate ratio of A by B. Okay, so in this type both the antecedent, that is A or numerator, or the consequent, that is the denominator, are multiplied by the same factor. In this case the same factor is M. Okay, so for example the ratio of A to B is 2 by 3. Let A is to B is equal to 2 by 3. Then let's say I take M is equal to 2. So into 2 by B into 2, that is equal to 2 into 2 by 3 into 2, that is equal to 4 by 6. Okay, so we will say 4 by 6 is the duplicate ratio of 2 by 3. Okay, duplicate ratio 4 by 6. Okay, so let's see continued ratio. So in a continued ratio, 3 or more quantities are connected. Okay, in such a way that the ratio of the first to the second is equal to the ratio of the second to the third. Okay, continued ratio is nothing but if A is to B. Okay, so there are 3 or more quantities connected. So A is connected to B and B is connected to C. And what is written here is A is to B is equal to B is to C. So A by B is equal to B by C. If this happens, then we say that this is a continued ratio. Okay, so A is to B is actually equal to B is to C. These two are if same, then we say that the ratio is called continued ratio. Okay, so for example what we can see is, let's say 1 is to 2 is equal to 2 is to 4, right? 1 is to 2 is equal to 2 is to 4, because its simplified version is 1 is to 2, right? So these two are basically same. Okay, so this is an example of continued ratio. So let's see the triplicate ratio. So triplicate ratio is a type in which both the antecedent and consequent are cubed. Okay, so you have A by B, where B is not equal to 0 obviously. So what happens is, for triplicate ratio A cube by B cube. Okay, so what you have right now is A cube by B cube, and initially you had A by B. Okay, so triplicate ratio does nothing but just cubes the numerator and cubes the denominator. Okay, then what you are left with is A cube by B cube. Okay, so this is an example of triplicate ratio. So if we have A is to B is equal to 2 by 3, what will happen is TR by triplicating the ratios, what will be happening is 2 cube by 3 cube, that is nothing but 8 by 27, right? So this is the answer. So let's see proportion. Okay, so proportion is nothing but a mathematical statement that establishes the equality of two ratios. Okay, if we say two ratios are equal, then we say that they are proportionate or they are equally proportion. Okay, so it is represented as A is to B is equal to C is to D, and signifies that the fraction A by B is actually equal to C by D. So A by B is equal to C by D, imply A is to B proportion C is to D. Okay, or equal to A is to B equal to C is to D. This is what proportion is. Okay, so let's see the type of proportions. So there is inward. There are actually 5 types of proportions. The first kind is called direct proportion. The second type is called inverse proportion. Third type is called joint proportion. And the fourth and fifth are called continued and compound proportion respectively. Okay, so we'll start with the direct proportion. Then we'll see what is the relation between direct proportion and inverse proportion. We'll explore inverse proportion in detail. Okay, then we will go forward for joint proportion, and then we will see continued and compound proportion. Okay, so let's start describing what direct proportion is. So let's see what direct proportion is. So in this type, as one quantity increases or decreases, the other quantity also increases. Okay, in the same proportion. Okay, so if A is to B is directly proportional to C is to D. Okay, then if A increases, okay, then C increases, and the increment speed is proportionate. So what do I mean by increment is proportionate? That is, if so, this is directly proportional to C by D, imply A by B is equal to C by D. So if 2A is multiplied by 2, okay, the increment is 2A. Then here the increment will also be 2C. Okay, so if A becomes 2A, then C becomes 2C. Okay, this kind of increment. And if B becomes B by 2, then D becomes D by 2. If B becomes 2B, this implies that D becomes 2D. This kind of increment. Okay, then we will say that these two ratios are directly proportionate or direct proportion. So let's see what inverse proportion is. So inverse proportion occurs when an increase in one quantity leads to an corresponding decrease in other quantity, and vice versa. So it can be represented as A by B is equal to C by D. So if A by B is equal to D by C, this is written as A is to B is inversely proportionate to C is to D, or A is to B is directly proportional to D is to C. Okay, whereas the two ratios are A is to B and C is to D. Okay, you can write here that you can just alternate the side of the ratio in which the quantities were written, and you can use the directly proportionate symbol. Okay, or you can write this as this. Okay, you can directly write this inversely proportionate. So if A is to B is inversely proportionate to C is to D, okay, then what will happen is A by B is equal to D by C. So if A becomes 2A, then D becomes 2D. Okay, here you can see that we are comparing A is to B and C is to D. So if A becomes 2A, D becomes 2D. Okay, and if B becomes B by 2, C becomes C by 2, and B becomes 2B and C becomes 2C. Okay, D becomes D by 2, what will happen is A become A by 2. Okay, so the left hand side of the ratio directly relates to the right hand side of the ratio. In that way, we can say that these are inversely proportional quantities. Okay, so let's go forward. Okay, so you can see the comparison. Let's compare. A is to B is directly proportional to B is to C, and A is to B is inversely proportional to B is to C. That is actually equal to, sorry, B is to C, C is to D. That is directly proportional to D is to C. Okay, so if A becomes A by 2, here B becomes B by 2. Sorry, not to B, this should be C is to D, right? So this becomes C by 2. And if B becomes 2B, D becomes 2D. But in this case, if A becomes A by 2, here D becomes D by 2. Okay, initially here. So D becomes D by 2. And if B becomes 2B, C becomes 2B. Okay, whereas we are only comparing A is to B with C is to D. Okay, so let's go forward. So let's see the third kind of proportion, that is joint proportion. So joint proportion involves the comparison of 3 or more quantities. Okay, so you have 3 or more quantities, that is A is to B is equal to C is to D is equal to E is to E by F. Okay, so you have A is to B, C is to D, and E is to F, and you are comparing these three. So this will be called joint proportion, whether they are equal or there is an inversely proportional here. Okay, you are just comparing any three and then two or three. Okay, then they are called joint proportion. Okay, example is right here with equality, that is directly proportion. Okay, so let's see the fourth kind of proportion, that is continued proportion. So in continued proportion, what happens is there are three or more quantities that are connected in such a way that the ratio of the first to the second is equal to the ratio of second to the third, and so on. Okay, that is called continued proportion. Okay, so A is to B, B is to C, D is to E, C is to D, D is to E. These are all same, equal. Then what we say is, and there are more than three proportions or ratios, and they are connected. Okay, so in what way connected? They are equal. Okay, A is to B is equal to B is to C is equal to C is to D is equal to D is to E. So for example, 1 is to 2, 2 is to 4, 4 is to 8. Okay, 8 is to 16. Okay, just see, these are all actually equal. So this kind of proportion will be called continued proportion. Okay, so let's see the fifth kind of proportion, that is compound proportion. So compound proportion combines the concepts of direct and inverse proportion. Okay, so compound proportion is nothing but it combines the concept of direct and inverse proportion. Okay, so it is represented as A by B is equal to C by D, and E by F is equal to G by H. Okay, this kind of proportion is called compound proportion. So let's see the types of questions that are being asked in the exam. Okay, on this ratio and proportion topic. So the first kind is called simple ratio problems. Okay, we'll see these. Okay, what are simple ratio problems and how to solve them and how to tackle the various concepts. Okay, so the second kind is proportional division problems. Third kind is called combined ratio problems. Then the fourth kind is called inverse proportion problems. The fifth is called mixture problems. Then we are left with age problem, speed and time problems, and percentage and profit loss problems. Okay, so let's explore with simple ratio problems first. So simple ratio problems, compare quantities using given ratios and find missing values. Okay, you have to do what? You have to compare quantities. Okay, and what you need to do is you need to use the given ratios. Okay, and find missing values. So missing values. So task is find missing values. So problem number 1, the ratio of boys to girls in a class is 3:2. So 3:2 is the ratio of boys to girls. So if there are 25 students in total, how many boys and how many girls are there? Okay, so 25, right? So let boys be what? 3x and girls be 2x. So the whole will be 5x, as 3x plus 2x is equal to what? 5x. So 5x is equal to 25. This implies that x is equal to 5. So this implies that 3x is equal to 15 and 2x is equal to 10, right? So number of boys is equal to 15 and girls is equal to 25 minus 15 is equal to 10. Or we can say that 5 into 2 is equal to 10. Okay, so this will be the correct answer. So number of girls is equal to 10. So let the number of boys be 3x and let the number of girls be 2x. So what we are left with is 5x, as their sum is 5x. So 5x is equal to 25. So x is equal to 5. 25 by 5. So calculate the number of boys and girls. So number of boys is equal to 3x. So that is 3 into 5 is equal to 15. And number of girls is equal to 2x. That is 2 into 5 is equal to 10. Okay, so there are 15 boys and 10 girls in the class. So let's see the second kind of question that is being asked. That is the proportional division problem. So distribute the quantities in proportion to give a ratio. So let's see. So divide 600 among 3 friends in the ratio 2, 3 and 4. So let's say first friend have 2x, second friend had 3x, Fourth friend is got 4x. Okay, so their sum will be what? Sum will be 2x plus 3x, 5x plus 4x is equal to 9x. So 9x is equal to 600. This implies that x is equal to what? 600 by 9. So this will be equal to 200 by 3. That is equal to what? 66.333. Okay. So for x is this. So for 2x, for 3x, for 4x, let's see what will happen. So share for the first friend will be 133.33. Okay. So the share for the second friend will be 3 by 9 into 600, that is 200. Okay. The share of the third friend will be 266.67, as 4 by 9 into 600 is equal to 266.67. So the first second gets approximately 133.33, the second one gets approximately 200, and the third one approximately gets 266.67. So combined ratio problem. So solve problems involving more than two quantities and their ratios. So the ratio of apples to banana to oranges is 2:3:5. If there are 40 fruits in total, how many of each type are there? Okay, the ratio of apples to banana to oranges is 2:3:5. So let their quantity be 2x, 3x and 5x respectively. So their addition will become what? 10x. Okay, so basically 10x is equal to 40 fruits. So this implies that x is equal to 4 fruit. Okay, since x is equal to 4 fruits, this implies that 2x is equal to 8 fruits. And 3x is equal to what? 12 fruits. And 5x is equal to what? 20 fruits. Okay, that is what we have here. 2x, 3x and 5x. Okay, 2x is equal to 8 fruits, 3x is equal to 12 fruits and 5x is equal to 20 fruits. So solution will be, let the common ratio of factor be x. So their sum will be 10x, and then what we do is we equate 10x with 40 and we are left with x is equal to 4. X is equal to 40 by 10, that is equal to 4. So then what we do is we calculate the number of each type of fruit. So number of apples is equal to 2x, that is 2 into 4 is equal to 8. And number of bananas is equal to 3x, that is 3 into 4 is equal to 12. So number of oranges is equal to 5x, that is 5 into 4 is equal to 20. There are 4 apples, 12 bananas and 20 oranges. Okay, so this is the final answer. 4 apple, 12 banana and 20 oranges. Final answer. So let's see the fourth kind of question that is being asked, that is on inverse proportion problems. So find the relationship between two quantities that are inversely proportional. Okay, so if a car covers a certain distance in 4 hours, how much time will it take to cover the same distance at speed twice as fast? Okay, so let's see. So let the original time taken be t hours. Okay, so let originally the time it takes is t hours. So given speed is twice as fast, so the new time taken will be t by 2 hours because it takes half as time. So the time taken at twice the speed is t by 2 hours. So we have t is equal to 4, then t by 2 is equal to 2 hours. Okay, so we have completed the fourth kind of question that is being asked. So let's revise what we have studied in this lecture. We studied what ratio is. So ratio is a comparison between two quantities. Okay, so typically expressed as A is to B and is pronounced as A to B or A is to B. So it represents the relationship or relative size between the two values. Okay, so there are 5 types of ratios: simple, compound, duplicate, continued and triplicate. So simple ratio was nothing but a basic comparison between two values or two quantities. And 4 by 6, if we take an example, its simplified version is 2:3. So 2:3 will be called a simple ratio. Okay, it can't be further simplified. So let's see what compound ratio is. Compound ratio was nothing but the result of 2 or more ratio being multiplied together. So we had two ratios, A is to B and C is to D. By multiplying them together, that is A by B into C by D. What we are left with is AC by BD. Okay, so AC to BD will become the new compounded ratio. So let's see what is duplicate ratio. Duplicate ratio was nothing. If you are given A by B or A is to B, then what you do is you multiply with a non-zero value or non-zero constant, that is M, let's say. So AM is to BM is called the duplicate ratio of A is to B. Okay, so what you do is we multiply something to the antecedent or numerator and the consequent, that is denominator, okay, by same factor. So for example, 2 by 3 is actually duplicates to 4 by 6. So 4 by 6 is the duplicate of 2 by 3. So let's see what continued ratio was. So continued ratio was nothing but 3 or more quantities connected in such a way that ratio of the first is to second is equal to ratio of the second is to third. So an example we took 1:2 is equal to 2:4, because after simplifying it became 1 by 2. Okay. So triplicate ratio. In this type, both the antecedent and the consequent are cubed. So if you have A by B, then after cubing them, what you are left with is A cube by B cube. Okay. So for example, you took 2 by 3, that triplicate ratio will be 2 cube by 3 cube, that is 8 by 27. Then we saw what proportion was. Proportion was nothing but a mathematical statement that established the equality of two ratios. Okay, so if A is to B is equal to C is to B, we say that A is to B is proportion to C is to D. Then what we saw was types of proportion, that there were 5 types of proportion, that is direct proportion, inverse proportion, difference between these two, joint proportion, continued proportion, and compound proportion. And if there are any relation between these, we have already studied. Direct proportion was nothing but if A is to B is equal to C is to D, that is A by B is equal to C by D, then we say that A is to B is directly proportionate to C is to D. So what is inversely proportion? So A is to B is equal to if D by C, and then it will be called as A is to B is inversely proportional to C by D. Okay. If A increases by 2x speed, then D increases with 2x speed. But in inverse proportion relation, if A is to B is inversely proportional to C is to D, if A increases in 2x speed, then D increases in 2x speed. Okay. The first quantity gets influenced by the next quantity in the next ratio. Okay. Second quantity of the next ratio, and the second quantity of the first ratio gets influenced by the first quantity of the second ratio. Okay, so we then saw joint proportion, that is A is to B is equal to C is to D is equal to E is to F, that is involving comparison of 3 or more quantities. Then we say that it is joint proportion. Then we saw continued proportion, if A is to B is equal to B is to C is equal to C is to D is equal to D is to E, then we say that these proportions are continued proportions. Okay, then we saw what compound proportion was. So compound proportion was nothing but A by B is equal to C by D and E by F is equal to G by H. That is, there are concepts. Compound proportion combines concepts of direct and inverse proportion. So here what we are given is concept of direct and inverse proportion connected in one. Okay, that kind of concept is called compound proportion. So we saw the all 8 kind of questions, simple ratio problems. Now we have covered up to 4 kind of problem, that is simple problem, simple ratio problem, proportional division problem, combined ratio problem, and inverse proportion problem. So this is all for this lecture. Thank you.